So in that last video, we kind of hinted at the idea of a limit. So we're going to talk about the properties of limits. We've seen this before, most of us at least. So we'll work on it in class. But right now we're going to talk about some of the properties. Remember, x is approaching some. I guess this says c if you can't read it. X is approaching some c value. But it never actually gets there. So the function, what we're taking the limit of, it never actually gets there, but it approaches whatever the limit is. So it's never actually happening; it's just approaching and then that's what the limit is. So let's talk about these things. If you're taking the limit of two things, you can actually take the limit of those things separately and then add them together. That's what this means, because they're saying that the limit of f is L and the limit of g is m. So you can just take the limits separately and then add them together. So if you have stuff being added, most of these everybody I feel like understands anyways. Same with subtraction, same with the products. If you have a constant out in front, you can take the constant out and then evaluate the limit. That's what it's saying. If you have a quotient, then you just still evaluate them individually. This is not derivatives. I feel like people are going to get it confused with the derivative rules. You don't have to do a quotient rule like low d high minus high d low. That you don't have to do for limits. You can just do almost everything individually. Even like with powers. I'm going to just write this one down. Limit as x approaches c of f of x. If there's an exponent on this, some type of exponent, we'll call it z. No, not z. Some rational exponent. You can write it as a fraction. So nothing that's like irrational, like square root of 2 or something. If you have something like this, then this part in here is what you can actually take the limit of, and then so that would equal the limit, which is the limit of f is L. That's what we said at the top, and then you would still use the same exponent. So still, you can just pretty much go inside your function and take the limit. That's actually number 6, the power rule. But let's look at an example for these properties. So here is one where the addition and subtraction rule. You can just evaluate these limits individually. So as x is approaching c, it's pretty much just direct substitution. If x is approaching c, then x cubed approaches c cubed. Same with the x squared. That means we have 4. We can pull the constant out. That's the constant rule. And then it would be c squared. And then the limit as x approaches c of just -3, well, there is no x, so it's just going to stay -3. That's what the limit is. We actually didn't need to see that. You just plug in stuff in. That's called direct substitution. I also want to mention that if we say x approaching 3, that means we're approaching from the left side, which means x goes from like 2.9, 2.999, 2.9999999. It's getting closer and closer to 3 from the left side, from the smaller side, and also from the right side, which would be 3.1, 3.0001, 3.00001, approaching 3 from the top side, so a little bit bigger than 3. So that's what this is a two-sided limit. So if we evaluate with direct substitution for this, what do we get? We get x squared, x is approaching 3, so that's approaching 9 squared. 3 squared, which is 9. And then 2 minus 3, which is -1. So this approaches -9. So this limit is -9. Fairly straightforward. Here's a special limit we can evaluate, so that's the answer. If we have the limit, so this will be c, as x approaches 0 of sine x over x. What does this equal? So this one is a good, if we use direct substitution, we get, what's the sine of 0? Sine of 0 is 0. And then we get 0 over 0. So if you remember, we could use L'Hopital's rule on this, but we're supposing that we don't know that. What I would do for this one, and what has been done for this one, is to plug this into your calculator in your y equals. So it would be y equals sine x over x. And then change your increments to start from, I suppose we could go on either side of 0. We could do like negative 0.3 and increment by 0.1. So the change in your table would be by 0.1 TBL. This is on your graphing calculator. So this is the start. And then increment by 0.1. So then the next one would be negative 0.2, negative 0.1, and then 0. And then it would start counting upwards. And if you plug these in, you would actually approach closer and closer and closer to 1. This would be like 0.98507, 0.993. It's getting closer and closer to 1. 0.99833. I mean, I wouldn't be able to evaluate these by hand because I don't know the stuff for that. So then when you plugged in 0, there would be no value in your calculator, and then after 0 it would go back to 0.99833. So it does not depend on what the function is at this specific x value, because we're never thinking about, I mean, with direct substitution we are kind of thinking like, okay, we could just plug it in. But if we can't plug it in, we can still get a limit because the function approaches something rather than actually getting there. Hopefully that makes sense. This and then this would be 0.9335 and 0.98507. You could see that if you're on your calculator if you did it. So this actually evaluates to 1 because both sides are approaching 1. If you approach 1 from the right side, or sorry, if you approach 0 from the right side, you're approaching 1 because that's close to 1. And then if you're approaching from the other side, the left side, same thing. So there you have that. I think I'll be done with this video.